Okay, welcome to lab. We'll get started here in just a second. We're actually, like I mentioned before, just going to wrap up talking about nomenclatures. We're going to finish up the lecture. And then, like I said, they should be set up to do the study assignment there. So again, we'll give everybody a couple of minutes here to get in, and then we'll continue on and finish up the lecturing part. And obviously type here. Looks like most of you are doing that. Okay, so we're going to, like I said, finish up talking about nomenclature. We have just one more aspect of naming to talk about, one more type of naming, and then we've named everything, I think. But before we begin, is there any questions on any of the type of naming that we talked about kind of up until this point? It's pretty much been ionic naming. So we had our type 1 and our type 2. So again, just a sort of a highlight again, as we talked about, type 1 is a metal and non-metal, and that's an ionic compound. And always when you have that metal and non-metal, it's always the metal that's really important. And in a type 1, the metal will be from group 1, 2, 3, zinc, cadmium, or silver. And again, really what that means is that metal has a fixed charge. And when we name those guys with fixed charges, that's a metal and a non-metal, we just use the whole name of the metal. And again, the non-metal gets that IDE. Again, no prefixes or anything with it. We don't have to do a Roman numeral if it is a group 1, 2, 3, zinc, cadmium, or silver metal that's involved. Type 2, as we talked about, also a metal and a non-metal, also an ionic compound. And again, here the metal is the important one. And the metal in a type 2 compound is a transition metal, except for the zinc, cadmium, and silver. And as we also saw, just a little bit outside of that area, to the right of the transition metals, below the staircase, things like lead, tin, antimony, bismuth, in that sort of area, even though they again are technically not transition metals, they are named the exact same way as transition metals. And what all those really have in common is they have a variable type charge. So in different cases, they may have different positive charges. So the way we name those, again, is just like we do type 1. We use the whole name of the metal, the IDE on the non-metal. The only additional thing is we include a Roman numeral. And again, the Roman numeral is for the charge on the positive metal. So if you take out that positive metal, what the positive charge is on one of them is what the Roman numeral indicates. Again, not how many metals you have or anything like that, the actual charge. Same thing as before. We don't use any prefixes or anything like that with type 1 or type 2 compounds. We also saw polyatomic ions, which are groups of nonmetals that are held together really through covalent bonding. But as a whole unit, once they're bonded together, they do have a charge, which is what makes them ions. And with those, we pretty much just use the names of the polyatomic ions. For the most part, though, as we saw, most of them are negatively charged, which means when they do sort of hook up with somebody, usually it'll be a metal. And what we do is sort of fall back to type 1 or type 2 naming. Again, if that metal needs a Roman numeral, you should put it. If the metal doesn't need a Roman numeral, you should not. And again, the main important thing on that guy as well, if you have more than one polyatomic ion, then you do need to put those parentheses around it. Put the little subscript on the bottom there to indicate how many you have of those guys, just to include that. And we finished up talking again, that's not too long ago, about 20 minutes ago, about acids. Acids are, again, basically the cation is always H plus is the cation. And basically the anion sort of determines whether or not, or sort of how you name the acid. So if your acid does not have oxygen in it, those are the guys that start with hydro and something ic acid. And if it does have oxygen in it, it will contain one of those polyatomic ions like we saw. And again, if that polyatomic ion ends in 8, ATE, the acid will end in IC. So it'll be something ic acid. Again, no hydro on that one because it does have oxygen. And again, if you have oxygen and it ends in ITE, the acid will end in OUS, acid. So like HNO2, like we saw, was nitrite, becomes nitrous acid. Again, no hydro in it because it does have oxygen. We do typically, again, put the aqueous symbol next to acids to indicate that they are acids. And that gives us sort of our difference between that and something that just has hydrogen in front of it, like hydrogen chloride. Again, if you put the AQ next to HCl, it becomes hydrochloric acid, and it's the acid version of it rather than, say, the gas version of it. Any questions on any of that naming that we talked about? All right, so the very last type of naming actually involves two nonmetals, and these are covalent compounds. These are guys that are going to share electrons. And there are certain things that do have common names. And there's some that we should always go by their common names. And the most important one almost is H2O. H2O is water. You should use water. You shouldn't use dihydrogen monoxide or anything like that because nobody wants a refreshing glass of dihydrogen monoxide. So it is water, not a trick question or anything like that. A couple other common ones, NH3. Now, NH3 is different than NH4 plus. That NH4 plus was a polyatomic ion. This is all neutral, NH3, and this is ammonia. So ammonia is different than ammonium that has a charge. And again, we use a common name here. And another one that usually most people will use a common name is CH4. And CH4 is the simplest organic molecule you could have. And that is what is known as methane. So for these guys here, obviously you should use the common names and not more of the type 3 type names that we come across. We also talked about it earlier, but when you do have hydrogen in front of something that's not an acid, again, it's considered H plus and kind of Cl minus, even though technically these are both nonmetals. But hydrogen, again, has some of those unique properties. So even though they're really nonmetals, we still would just call this, as we saw earlier, hydrogen chloride. Again, not an acid because it doesn't have the AQ next to it. You know, even if you had two of them, for example, like we saw with that H2S, this would still be called hydrogen sulfide, and this is a gas. And again, it's thought of as being H plus, and as we saw, S2 minus. So hydrogen, again, a little unique in the sense, even though technically speaking, it's non-metal in each of those. And you might be tempted to sort of follow the rules we're going to talk about here in just a second. But again, if you do see something with hydrogen that's not an acid, basically it's hydrogen, and whatever the negative guy is pretty much how you name it, even if there's more than one hydrogen, as you can see there on the bottom with hydrogen sulfide. And again, it just has to do with hydrogen and some uniqueness of hydrogen, I guess, as we saw as well. Hydrogen can go negative when it's after a metal. So that's a little something to keep in mind. So when we talk about type 3 compounds, this is finally where most people always want to use those things. This is where we use prefixes. So this is really the situation where you should use prefixes, is when you have a type 3 compound. Again, 2 nonmetals going to have sharing of electrons here. Prefixes is what we use. So how do we go about doing this? Pretty much the first element in the formula, you use the entire name of it. So the first one in the formula, entire name of that particular element. And you would also use the appropriate prefix for how many there are. Now, for the second guy, it's named just like normal with the IDE at the end of it. So whole name for the first one. And the second one, just like we've been doing, we drop the last part of that nonmetal and put that IDE in here. And then for both names, in most cases, we use the appropriate prefix. Now, prefixes, as we will see, right? Like mono for 1, di for 2, tri for 3, tetra for 4, and so forth. So these prefixes we use, the only difference is we do not use mono on the first name, but you can use mono on the second name. So for example, if you had CO, the nice thing about type 3 really is the idea that you don't really have to do any balancing. You don't have to worry about charges. They are actually the easiest ones to do. They should take you the least amount of time to name and write the formulas for. But with that being said, I will say that people have a tendency to screw these up the most because they want to kind of do all those weird things, balance charges, figure out charges, do weird things. So really when you do this, you just need to really see how many of each element are there and then choose the appropriate prefix. So when we look at CO, there's only 1 carbon, which the prefix for 1 would be mono, but we don't use mono on the first name. So that means we just use the whole name, which would be carbon. There's 1 oxygen, which means the prefix would be 1 and the prefix there would be mono. And we do use that on the second name. And there is another consideration when we have prefixes. We use our second name with the IDE out of it, but we also will sometimes have this happen here where we get a couple of vowels that sort of back up to each other. So if we left it the way it is, we would call this carbon monoxide, which is not really what it's called, as you might know. So what we typically do is when you get a couple of vowels that back up to each other, we typically drop the vowel off of the first guy. And this becomes what we do know it's called, carbon monoxide instead of monoxide. So this becomes carbon monoxide, and that would be the proper name for it. Again, didn't have to worry about charges or anything like that. Just simply had to figure out how many were there and use the correct prefix. And this is a very good illustration that you don't use mono on the first one, but again, here you can use mono on the second one. Any questions on that there? So here are the prefixes and a couple other considerations just in case. I don't know, maybe you get there. 9 is nano and 10 is deca. I don't know if you get that far usually, but you can. But a couple other things that happen, again, as I mentioned, you get those prefixes that have the vowels. So usually the few common ones is to 2 O's. So again, we drop the first O off of the prefix like we just did. Also an A and an O is also another common sort of prefix coming into the first letter. Again, dropping the last of the prefix. So for example, if you had tetraoxide, here the A and the O, we would get rid of the A and just become tetroxide there with no A in the end there. 2 I's are actually okay. So they're actually okay in the terms of the I's. So these are really the sort of the ones where the prefix and the first letter of the element back up to each other in that kind of OO situation or AO situation. We typically will drop the last vowel from the prefix there. as we can see in both of these names here. Again, dropping that vowel from the prefix. And as we saw earlier, typically we do use obviously the common name. The sort of systematic name for water obviously would be something like dihydrogen monoxide, which again, we don't really use it. Or nitrogen trihydride for the ammonia, which we don't use that name either. So again, that one along with the CH4 you should know, which is methane, we use our common names for. All right, so you got a few here. So why don't you give that a go? I'll give you some names to write formulas for, and you can write those. So. All right, so why don't you give the names of the guys on the left and the formulas for the ones on the right and see what you come up with. Yeah, it is. It is sulfur. Thanks. There's a few different ways people spell it. Like a pH I've seen as well. Exactly. Yeah. Okay, so let's take a look at these. And again, like I said, these really, the nice thing about type 3 is it really should go pretty quick because you really don't have to figure out anything other than how many of everybody that you got going on there. So here, first off, we see I and O, which are both nonmetals, which automatically tells us it's type 3, which means, again, good news is you don't have to worry about too much. We just need to figure out how many we got. So 2, the prefix for 2 is di. So this would be diiodine. Again, here we would use the entire name. 7, the prefix for 7 is hepta. And here, if we went straight with the hepta, we would then get the AO combination. So we will drop the A off of the prefix and the O is okay. And like I said before, the 2 I's seem to be okay. So you don't have to worry about dropping one of the I's or anything like that. It's really more the A and the O and the O and the O that comes together. So diiodine heptoxide. Here we have C, which is carbon, O, which is oxygen. Again, both nonmetals. One carbon by itself, mono would be the prefix, but again, we do not use it on the first name. So we got carbon, and then we have di, which is the prefix here. So that's going to be dioxide. So this would be our carbon dioxide. Same thing coming this way. We got phosphorus and Cl, which is chlorine. Again, both nonmetals, just one phosphorus there. So again, the prefix would be mono, which we will not use there on the first name. So we'll use phosphorus. Again, prefix here is 3 for trichloride. So phosphorus trichloride in that case. Any question on any of those there? And coming here from the name to the formula, also super easy-ish. As soon as you start seeing these prefixes like di and penta, you know that you're dealing with this type 3 situation. So di is 2, nitrogen is N, so N2 is where that comes from. Penta is 5, oxide is oxygen, so O5, just like that. Again, don't have to worry about balancing anything or anything like that. Just simply put our letters and our correct numbers. Sulfur hexachloride, I'll spit that out. I don't see a prefix here, but I do see it here. So that again implies that this is going to be nonmetal, which sulfur and chloride is. And no prefix on the first one means we just have one, which would be S. Hexa is 6, and chloride is Cl, so SCl6. And lastly here, carbon tetrafluoride. Again, no prefix here, but I do see the tetra prefix here. Tetra meaning 4, with no prefix, just one carbon, and 4 fluorines. Yeah, and there you go. So like I said, these are really the easiest. They really should take you probably the least amount of time of everybody. But I will be honest with you, like I've said before, people tend to screw these up because they want to do all these weird things, you know, when they go about sort of naming these things. So this is really the only place, as you can see, that you should be using prefixes. And again, it's only for type 3 compounds, nonmetal and nonmetals together. And that is really the only place you should use a prefix. The only other place that you would maybe see a prefix is in a polyatomic ion, where the actual name is a prefix, like dichromate. Like, for example, the actual ion itself has a prefix in it, like Cr2O72-, that's dichromate. So that's really the only other place that you would see a prefix, but that's part of the actual name of the polyatomic ion. Nowhere should you be doing anything like, you know, some Roman numeral 3 and some dioxide or something like that. There should be no place where you have both of that happening, really, because it's just going to get one of those. So Roman numerals only for type 2, where you have a transition metal basically and a nonmetal. Prefixes really only for type 3, where you have 2 nonmetals together. There's very, very little chance that those should ever be mixing together, like I just crossed out there in the middle of the screen. Any questions on type 3 compounds? Okay, so that actually wraps up chapter 3 and the nomenclature. I think we've now talked about how to name everything that you'll need to know till you take 200B, and then you'll name something else. But for now, everything that you need to know. So you should now be able to really complete study assignment C, which is the one we kind of switched from yesterday to today. And again, that should be in the back of the book there, and that should be all about nomenclature. So I think there's a lot in there in terms of names that you have to do, formulas that you have to write and stuff like that. So I do know it's a little bit long and stuff like that. So I'm going to make it due officially tomorrow. But I'll put the box up there for you to upload it. If you finish it before then, you can, but it'll officially be due tomorrow. by the end of lab. But hopefully you'll knock it out hopefully today and get done with it and get it out of the way. But officially that's when it'll be due. I do know it's a little bit longer of a one, I think. So you might need a little bit more time. And since we took some of the time here to lecture a little bit, a lot of time, I suppose, but you can have that extra time if you need it. But the box will be up there for you to upload it in just a few minutes. But again, official due tomorrow, the latest. Any questions on that or anything else that we've been talking about in terms of lecture here? Okay, so that's what you should be doing now. You should be working on your study assignment. If you have questions, obviously I'll be here to answer and be happy to answer those for you. A reminder again, our next exam I think is rolling up on us on Monday, if I'm not mistaken. I could be wrong, but I think it's coming soon. So just keep that in mind. And if I'm also correct, what we just finished should be the last bit of information that will be on the exam. So everything, I think, through what we just finished here with nomenclature, I think should be everything that should be on there. Any questions on any of that? Obviously, tomorrow we'll be hitting into, I think, reactions, if I'm not mistaken. So I think that's where we're going next. And we'll start that new lecture, obviously, tomorrow. All right, so for the rest of the time, obviously, work on your study assignment. If you have questions, obviously, feel free to ask. You're welcome to hang out or pop back in, whatever you like to do. Otherwise, I'll be quiet for the rest of the time probably. And I'll see you tomorrow if you're, going to pop out.